So folks, trying to make up some time here. Welcome back to COM-HPC Mini Academy. We're now in session 3 of 4, during which we're going to be looking into the COM-HPC design guide. There have been some updates since the first design guide was released a couple years back. And the person who's going to be walking us through that is Peter Hunold. Peter put together a nice video for us that does a walkthrough for about 15 to 20 minutes of not everything, but a lot of the key tips and tricks that you'll need to know to start hitting the ground running with the COM-HPC design guide. So before we get into that, we'll go back through the housekeeping really quickly. Just as a reminder, if you need to chat, there's a chat box that you can access on the right-hand side of your screen. Chat your messages into the box and then hit submit. One of the participants let me know that there is a character limit. Yes, it's about 500 characters. So if you got a long question, try to break it into parts, and we'll make sure that we capture enough of those, or as many of those as we can, in the closing panel session, which is the next session right after this. There's also a Q&A tab. I'll be monitoring both the chat box and the Q&A section. If you put your questions into the Q&A tab, same thing, an interface will pop up. You click submit, and then we'll harvest those. And I know that some of the members of the COM-HPC working group have been monitoring those and answering in real time. Of course, like I said, though, we'll also capture some of those and bring them into the panel session, which will be happening right after this. So at this point, I'm going to jump in and remind you before I start playing the video that all PICMG presentations are copyrighted and may not be recorded without prior permission. But let's take a look at what Peter Hunold has put together for us around the COM-HPC design guide.
Hello, my name is Peter Hunold, and today I'm going to give you a little introduction to the updated version 2.2 of the COM-HPC Carrier Design Guide. I have been working in hardware development at Kontron for 18 years. My main activity was and is the development of computer-on-modules with a focus on computer modules based on x86, respectively x64 technology. Let's start with a small overview. First, I'm going to tell you about the COM-HPC module-based specification document and why I think every carrier developer should have this document too. Then I will introduce the Carrier Design Guide, where I will give a few hints about the updates for COM-HPC Mini. This is not about listing all the changes. I will use a few examples to show how to read the Carrier Design Guide, especially for COM-HPC Mini carrier development. Why are specification and manufacturer information needed for carrier development? Before I give information about the updated Carrier Design Guide, I would like to say a few general words about the specification. First, it is important to know what information can be found in the specification. Here you can find a general introduction to the standard, the connector used, the different sizes, and the different pinouts. All of you are certainly familiar with this picture, which shows an overview of the different sizes well. The specification describes the different signals with voltage levels. General design information, such as a detailed chapter on loss budgets for high-speed differential interfaces, is also available. There is a general overview of the functions which describes which functions each COM-HPC module must have. Many of the functions described are optional or can be implemented in a scalable way. As an example, I'll take N-base-T Ethernet. A COM-HPC Mini or COM-HPC client module must support at least one N-base-T port. However, two can also be implemented. In the case of embedded DisplayPort, it is a module manufacturer's decision whether to support embedded DisplayPort on his module or not. So this feature is optional. Information about which functions are supported by the different modules can usually be found in the manuals of the module manufacturers. The point I'm trying to make is that for a carrier design, it's not enough to download the carrier design guide and just work with this document. The idea of the carrier design guide is to expand the specification and provide valuable additional information. However, every carrier designer should also have the COM-HPC specification. As mentioned, the manuals or datasheets of the module manufacturers are also essential when developing a carrier board. Depending on the features used, even more knowledge may be required. However, the carrier design guide is a good basis for carrier development and helps with its examples of various features. To come back to the Ethernet example. If a carrier is to use two N-base-T ports from the module, then it must be checked whether the desired module supports two N-base-T ports. Otherwise, this particular module is not suitable for this target system. Alternatively, a different implementation of the carrier can be chosen, so that the second N-base-T is implemented on the carrier, for example, via PICI Express. Where can I find information about the mini module in the COM-HPC standard? The specification is structured in such a way that the information about the COM-HPC Mini is described in a separate chapter, Chapter 10. Many contents from other chapters of the specification also apply to the COM-HPC Mini type. As an example, I would like to mention the chapter that describes the loss budget. The content of this chapter also applies to COM-HPC Mini since it deals with general signal integrity topics. Now let's go to the actual topic of the talk, the updated COM-HPC Carrier Design Guide and how to use it. As mentioned, this document is an extension to the COM-HPC specification and in my opinion contains a lot of additional information that helps in the design of a COM-HPC carrier, especially a COM-HPC Mini carrier. I would like to start by describing the structure of the Carrier Design Guide. In addition to the introduction and the subsequent appendix, there are three main chapters: reference schematics and block diagrams, PCB design rule summaries, mechanical considerations. The key chapter is certainly the chapter reference schematics and block diagrams. With version 2.2, information about the COM-HPC Mini has been added to the design guide. The design guide has not been completely rewritten for COM-HPC Mini, and there are no special chapters that only describe COM-HPC Mini. To describe the additional COM-HPC Mini information in the design guide, there are many special notes through the document, which are countersigned as described in the image. Now let's move on to the main part of the Carrier Design Guide, the chapter Reference Schematics and Block Diagrams. This part of the design guide includes examples of almost all important interfaces of the COM-HPC standard. The chapter is divided into over 20 subchapters. Of course, I can't show them all now, but I would like to present a few examples. Here I would like to show in particular how the design guide for COM-HPC Mini has been adopted. As first example, I'll take N-base-T Ethernet again. There is an example circuit for this interface in the Carrier Design Guide. In general, of course, it must be noted that the schematic examples given in this document are considered correct, but there is no guarantee of this. In addition, the circuits correspond to the time of creation. The carrier designer should therefore check whether the components used in the sample schematics are suitable for his application. For example, it should be checked whether the components can be used in the required temperature range or are available over the entire time of the product. A multi-manufacturer strategy for the selected components also often makes sense. For most interfaces, there is a circuit example in form of a schematic or block diagram. Various circuit examples cannot be included in the carrier design guide provided. The requirements of the possible systems and thus the possible schematics are simply too different for that. And, unfortunately, it cannot be guaranteed that this document will always be kept. The requirements of the possible systems and thus the possible schematics are simply too different for that. And, unfortunately, it cannot be guaranteed that this document will always be kept up to date. Nevertheless, the example circuits are also a great help in future when a carrier is developed. The components selected in the carrier design guide will continue to be a good starting point for research in the future, especially if you are developing a COM-HPC carrier for the first time. You will find many good examples and additional hints here. Back to the example N-base-T. Here is the node for COM-HPC Mini. This example applies to the COM-HPC Mini as well. The LED voltage feeds are left at 3.3 to allow sufficient forward voltage to operate the LEDs. That means COM-HPC Mini carriers can therefore use the same N-base-T circuit as the client or server type. A special adjustment of the carrier schematic is not necessary. With SATA, the implementation between COM-HPC client and server differs compared to COM-HPC Mini. In this case, the unchanged sample schematics are only valid for COM-HPC server and client. The required adaptation for a COM-HPC Mini carrier is described in the commentary. So, on a COM-HPC Mini carrier, additional series capacitors are required for the RX and TX signals, which are not shown in this figure in the design guide. Let's come to a third example which even overlaps somewhat with the SATA example in terms of content. PCI Express in COM-HPC Mini. COM-HPC Mini has 16 possible PCI Express lanes, namely PCI Express lane 0 to 15. This PCI Express group 0 is divided into two subgroups as with the COM-HPC client and server. There is PCI Express group 0 low for lanes 0 to 7 and group 0 high for lanes 8 to 15. In terms of the recommended fill order, COM-HPC Mini is similar to client type. The server type has a slightly different recommended fill order for group 0, which I don't want to go into further. However, there is an important difference in PCI Express group 0 between Mini and client type. The COM-HPC Mini uses a modified AC coupling capacitor concept in PCI Express group 0 low. For this PCI Express subgroup, COM-HPC Mini does not provide any AC coupling on the module. In this case, the coupling of TX signals must be done on the carrier. This is different for the PCI Express subgroup 0 high and for all lanes for the COM-HPC client and server type. In these lanes, the AC coupling capacitors for the transmit signals are located on the module. At first glance, this sounds unnecessarily complicated, but of course it has a technical background. With COM-HPC Mini, there's only one connector compared to COM-HPC client, which is only half as many available pins. Nevertheless, the standard was intended to create as many implementation options as needed. SATA, for example, is an interface that will probably play a smaller role in the future and may disappear altogether at some point. However, customers from the embedded market in particular would like to continue using this interface, and there was a desire from several module manufacturers to be able to offer this function with COM-HPC Mini as well. Therefore, some PCI Express signals have alternative functions. On PCI Express lanes 7 and 6, COM-HPC Mini modules can optionally provide the alternative SATA function. In addition to SATA, there's a second function that can be implemented as an option on some PCI Express lanes by module manufacturers. For PCI Express lanes 3 and 2, the modules can optionally each provide a high-speed signal pair for SGMII. These functions are often provided by the chipset as an alternative function on PCI Express signal pins, so that they can be made available by the module manufacturer without additional hardware effort. On the module, the chipset has only been initialized differently via software adoption, and the module can, for example, provide SATA on PCI lanes 7 and 8. Unfortunately, the required coupling capacitors differed between SATA, SGMII and PCI Express. If the TX coupling capacitors were on the module manufacturers would have to adjust the hardware for the module depending on the customer's application or choose a compromise. For SATA, AC capacitors would also have to be added for the RX signals. Therefore, it was decided in the standardization group that the appropriate AC capacitors would be selected by the carrier manufacturer for the lanes of group 0 low. The carrier manufacturer knows whether PCI Express, SATA or SGMII is used by the carrier. As mentioned, these alternative functions are module dependent. Whether SATA or SGMII is supported in the COM-HPC Mini module you have chosen, please refer to the manufacturer's datasheet or ask the manufacturer directly. See the Carrier Design Guide for examples of PCI Express, SATA and SGMII. There are also a few examples where there is no reference schematic but block diagrams of the required carrier circuitry. Sometimes a block diagram is easier to understand than a schematic. For other examples, such as USB 4, the PICMG is not allowed to insert the schematics into the design guide. However, a very good compromise was found with a block diagram in this case. Here, where an Intel retimer is used on the carrier, this feature must of course also be supported by the module itself. Further information about this retimer and the circuit itself can be obtained from Intel. As a final word to the chapter reference schematics and block diagrams, it should be said that it does not only consist of schematics and block diagrams. It includes many detailed explanations and lists that are very helpful. PCB design rule summaries. This section of the Carrier Design Guide has hardly changed from the previous version. The notes and rules described in this chapter apply to the COM-HPC Mini type just as they apply to the COM-HPC client and server type. Reference is also made here to some further documents from Intel and AMD, but some of them are under NDA. So you need an NDA to get access to the relevant documents. A few book tips are also included. Mechanical considerations. Also in the chapter Mechanical Considerations, there were no special adjustments for the COM-HPC Mini type. Here the general cooling concept with the heat spreader and various options for attaching the module with carrier and heat spreader are described. The cooling solution of the different systems can vary greatly depending on the system requirements. That's why I don't want to go into this area any further. I hope that this little introduction will motivate you to take a closer look at the COM-HPC Carrier Design Guide, or that you will recommend your colleagues to take a look. It will certainly help a lot in the design of a carrier and can also be useful in module development. I wish you all every success in your COM-HPC projects. Thank you very much.
Some really good stuff there from Peter. I, for one, am looking forward to going deeper into the carrier design guides in the next couple of months, and really helping PCB and hardware design engineers make the most of their carrier designs, and then, of course, on top of that, maximize COM-HPC Mini and other COM modules as well. So at this point, we're done with the third session, which will bring us to our final session of the day. And that is a multi-vendor Outlook panel, which is going to, oh, I promoted the wrong way, a different way now. You got it two different ways to access that multi-vendor Outlook panel, which is going to go over COM-HPC, COM-HPC Mini, COM-Express, what the differences are, when you should switch, and other tips for developing COM-based applications based on PICMG specifications. We're going to be joined there by Joel Finkel of Intel, Christian Nader of Congatech, Matt Burns of Samtech, and Peter Hunold here, who just walked us through the design guide. So we're really looking forward to seeing you over there in just a couple of minutes, and stay tuned.